Java Lambda expressions from the Jenkov website. So this is Jenkov, and this is an article about Java 8 and introduced new Lambda functionality in Java 8, which basically means we can write logic and pass logic without declaring the encapsulating class. So one of the criticisms on Java is its explicitness. Some of the explicitness resides from the requirement to write classes and many classes. So with lambdas we can write just the logic itself. So if we want to add a plus b, so we write the logic of a plus b instead of creating class and inside it a function that has the a plus b. And this is useful when we pass functions into another functions, into other objects, or when we use the stream API, then we want to do an operation on the stream. So we just write the logic. Let's read the article. He will explain it much better. Java Lambda expressions are new in Java 8. Java Lambda expressions are Java's first step into functional programming. A Java Lambda expression is thus a function which can be created without belonging to any class. This is just what we said. Write the logic, and it's not in any class, at least not as we the programmers write it. A Java Lambda expression can be passed around as if it was an object and executed on demand. Java Lambda expressions are commonly used to implement simple event listeners callbacks, or in functional programming with the Java Stream API. Java Lambda expressions are also often used in functional programming in Java. He has here also a video, but we'll continue with the article. Java Lambdas and the single method interface. Functional programming is very often used to implement event listeners. Event listeners in Java are often defined as Java interfaces with a single method. Here is a fictive single method interface example. So we have here an interface with a single method. The name of the interface is state change listener, so we expect to have a function on what to do when we have a state change. And we have public void on state change. We have the old state and the new state as two separate parameters. This Java interface defines a single method which is called whenever the state changes, in whatever is being observed. In Java 7, you would have to implement this interface in order to listen for state changes. Imagine you have a class called stateOwner which can register state event listeners. Here's an example. So stateOwner add state listener. It has a simple single method. It would add a state listener such that if you have multiple state listeners, you would call add state listener, listener 1, add state listener, listener 2, and then when the event happens, all these state listeners will execute. In Java 7, you could add an event listener using anonymous interface implementation like this. stateOwner, new stateOwner dot add state listener, and now we have this boilerplate which we try to get rid of in Java 8. New state change listener. So we do a new. Notice that we do a new on the interface. We didn't define a class. This is good, but still we don't want even to do this new state change listener new on the interface. Then we define the function again with its signature and then the logic. First, a stateOwner instance is created. Then an anonymous implementation of the state change listener interface is added as listener on the stateOwner instance. In Java 8, you can add an event listener using Java Lambda's expressions like this. New stateOwner. And now this is the difference. Add state listener. We don't do any new. We don't have any new on the function. We just give it the two input parameters that add state listeners expects an interface, right? It expects an interface with the signature. The signature is from two states to void, right? So we just give it the implementation and we say we have an old state, we have a new state, and the result of this, give me the old state. You give me the old state, give me the new state, and I will do something with it. The lambda expression in this part. So this is the lambda expression, the old state, new state, the parameters, and then what to do with them. The lambda expression is matched against the parameter types of the addStateListener method parameter. If the lambda expression matches the parameter type, in this case the state change listener interface, then the lambda expression is turned into a function that implements the same interface as that parameter. Java lambda expressions can only be used where the type they are matched against is a single method interface. Okay, so we can use it only when we have an interface of a single method it would match against it. In the example above, a lambda expression is used as a parameter where the parameter type was the state change listener interface. This interface only has a single method, thus the lambda expression is matched successfully against that interface. So the important point here is that we need an interface with a single method. Matching lambdas to interfaces. A single method interface is also sometimes referred to as functional interface. Matching a Java lambda expression against a functional interface is divided into these steps. So now it's describing when you write this implementation of the function, Java is strongly typed, and we like that it's strongly typed, right? We don't want to pass anything, so we want the compiler to fail if what we provide to it is not matching the interface that we give it. Does the interface has only one abstract unimplemented method? Does the parameters of the lambda expression match the parameters of the single method? So we need both the interface to be one abstract unimplemented method. Does the parameters of the lambda expressions match the parameters of the single method that it has? Does the return type of the lambda expression match the return type of the single method? If the answer is yes to these three questions, then the given lambda expression is matched successfully against the interface. So it's not enough that we provide the same interface. We also need the interface that has only one method to be abstract and unimplemented in the definition. Interfaces with default and static method. From Java 8, a Java interface can contain both default methods and static methods. Both default methods and static methods have an implementation defined directly in the interface declaration. So from Java 8 we can define some implementation in the interface itself. This means that a Java lambda expression can implement interfaces with more than one method as long as the interface only has a single unimplemented method. So this is interesting. This means that we can have an interface with multiple methods, but this interface would have only a single one abstract unimplemented method. So it's okay for the interface that we pass the function into to have multiple methods. We only need that this single method, the interface would have a single method which is abstract. In other words, an interface is still functional interface even if it contains default and static methods, as long as the interface only contains a single unimplemented abstract method. And he has a video about this. The following interface can be implemented with lambda expressions. So we expect to see here multiple methods. We see here one which is abstract, the printit. We have an interface named myInterface. It has one abstract method named printit, which receives a string, and it has also two more methods. One method is default, public void, and we see here the keyword default means it has some default implementation. And we have also a static method here. So this interface has three methods, but because it has a single, if it had multiple abstract methods, then we could not pass lambda expressions that implement it. Even though this interface contains three methods, it can be implemented by a lambda expression because only one of the methods is unimplemented. Here is how the implementation looks. My interface, string to print text. Lambda expressions versus anonymous interface implementations. Even though Lambda expressions are close to anonymous interface implementations, there are a few differences that are worth noting. The major difference is that an anonymous interface implementation can have state, member variables, whereas a Lambda expression cannot. Look at this interface. We have an interface named myEventConsumer. It has a method consumed, an abstract empty one. This interface can be implemented using an anonymous class implementation like this. New myEventConsumer, and we implement the method consume and do something with it. This anonymous myEventConsumer implementation can have its own internal state. Look at this redesign. New myEventConsumer, now we have a private member, event count, and we do something with the event count. It has a state. Notice how the anonymous myEventConsumer implementation now has a field name event count. A Lambda expression cannot have such fields. A Lambda expression is thus said to be stateless. And we like stateless, we like functional. In many cases, not 100% cases, in many cases we do like it. Lambda type inference. Before Java 8, you would have to specify what interface to implement. When making anonymous interface implementations, here is the anonymous interface implementation example from the beginning of this text. State owner, add state listener. New, we implement the anonymous class, new state listener, and we implement a function. With Lambda expressions, the type can often be inferred from the surrounding code. For instance, the interface type of the parameter can be inferred from the method declaration of the addStateListener method, the single method on the stateChangeListener interface. This is called type inference. The compiler infers the type of the parameter by looking elsewhere for the type. In this case, the method definition. Here is the example of the beginning of this text, showing the stateChangeListener interface is not mentioned in the Lambda expression. So we don't have types. We call stateOwner.addStateListener, and then in brackets we have old state, comma, new state, and we don't specify the types of the arguments in the Lambda definition. In the Lambda expression, the parameter types can often be inferred to. In the example above, the compiler can infer their type from the onStateChange method declaration. Thus, the type of the parameters, old state and new state, are inferred from the method declaration onStateChange method. Lambda parameters. Since Java Lambda expressions are effectively just methods, Lambda expressions can take parameters just like methods. The old state new state part of the Lambda expression shown earlier specifies the parameters the Lambda expression takes. These parameters have to match the parameters of the method on the single method interface. In this case, these parameters have to match the parameters of the onStateChange method. So we continuously see here how on one hand we reduce the amount of code that we need to write, but on the other hand, how the compiler still does checks. It wants to make sure that the old state and the new state parameters match the types. Public void, onStateChange, state old state, state new state. As a minimum, the number of parameters in the Lambda expression and the method must match. Second, if you have specified any parameter types in the Lambda expression, these types must match too. I haven't shown you how to put types on Lambda expressions parameters yet. It is shown later in this text. But many cases you don't need them. Zero parameters. In the method you are matching your Lambda expressions against takes. If the method you are matching your Lambda expression against takes no parameters, then you can write your Lambda expression like this. Open close curly brackets and then the implementation. Notice how the parentheses have no content in between. That is to signal that the Lambda takes no parameters. One parameter. If the method you are matching your Java Lambda expression against takes one parameter, you can write the Lambda expression like this. Single parameter in parentheses, and then the implementation. Notice the parameter is listed inside the parentheses. When the Lambda expression takes a single parameter, you can also omit the parentheses. So just parameter to the implementation. Multiple parameters. If the method you match your Java Lambda expression against takes multiple parameters, the parameters need to be listed inside the parentheses. Here's what it looks in Java code. Parentheses and the two parameters with the comma in between them. Only when the method takes a single parameter, you can omit the parentheses. Parameter types. Specifying parameter types for a Lambda expression may sometimes be necessary if the compiler cannot infer the parameter types from the functional interface method the Lambda is matching. Don't worry, the compiler will tell you when that is the case. Here is a Java Lambda parameter type example. So we specify here in the parentheses of the argument of the Lambda expression car. So we specify the type. As you can see, the type car of the car parameter is written in front of the parameter name itself, just like you would when declaring a parameter in method elsewhere, or when making anonymous implementations of an interface. So this var parameter types is now from Java 11, but we leave it for now because so this is a comment about let's go over it actually. Var parameter types from Java 11. From Java 11, you can use the var keyword as a parameter type. The var keyword was introduced in Java 10 as a local variable type inference. From Java 11, var can also be used for Lambda parameter types. Here is an example. Using the Java var keyword as a parameter types in Java expression, what does it give us? The type of the parameter declared with the var keyword will be inferred to the string type, because the type declaration of the variable has its generic type. So this helps when we have generic type, and it would be inferred, which means that the parameter type and return type of the function is string. Lambda function body. The body of the Lambda expression, and thus the body of the function method, is specified to the right of the arrow in the Lambda declaration. So we see the body on the right side of the arrow. If your Lambda expression need to consist of multiple lines, you can enclose the Lambda function by curly braces. Returning a value from Lambda expressions. You can return values from Java Lambda expressions just like you can from a method. You just add a return statement to the Lambda function body like this. Return and the return statement. In case all your Lambda expression is doing is to calculate and return a value, you can specify the return value in a shorter way. But they still use here the curly braces with the return keyword, but you can omit the return keyword if you omit the curly braces. So you can just do the parameters and then the return value without curly braces, and it would get returned. The compiler then figures out that the expression is the return value of the Lambda expression, hence the name Lambda expressions as expressions. Expressions here mean this is the value, the return value. Lambdas as objects. A Java Lambda expression is essentially an object. You can assign a Lambda expression to a variable and pass it around, like you do with any other object. Here is an example. So we have an interface, my comparator, Boolean compare, takes two values. We have a Lambda expression, takes two arguments, a1, a2, and then compares a1 to a2 in the Lambda expressions. This is the expression. We assign it to a variable, and then when we call and then we can use this Lambda expression because it's the interface and call the method compare. So it lets us quickly create the interface with just the body of the Lambda expressions without implementing the actual method. The first code block shows the interface which the Lambda expression implements. The second code block shows the definition of the Lambda expression, how the Lambda expression is assigned to the variable, and finally how the Lambda expression is invoked by invoking the interface method it implements. Variable capture. A Java Lambda expression is capable of accessing variables declared outside of the Lambda function body under certain circumstances. And he has a video about this. Java Lambdas can capture the following types of variables: local variables, instance variables, so it has access to external variables. Each of these variables will described in the following section. Local variable capture. Basically, we just mean here that we have access to external variables defined outside of the Lambda. A Java Lambda can capture the value of a local variable declared outside the Lambda body. To illustrate that, first look at this single method interface. So we have an interface named myFactory with a single function create. Now look this Lambda expression that implements the myFactory, and here we have a Lambda expression from Charles and we return a new string. Right now this Lambda expression is only referencing the parameter value passed to it, Charles, but we can change that. Here's an updated version that references a string variable declared outside the Lambda function body. So because we defined here the Lambda as a variable, so it still exists here, even if we would not define it, but when we would want to reuse it, then it has a reference to something external to the Lambda expression. Needless to say, a little bit shaky. I mean, we always prefer less state, but there are use cases for this. As you can see, the Lambda body now references the local variable myString, which is declared outside Lambda body. This is possible if and only if the variable being referenced is effectively final. Yeah. Meaning it does not, it's a string, so it's effectively final. It does not change its value after being assigned. If the myString variable had its value changed later, the compiler would complain about a reference to it from inside the Lambda body. Instance variable capture. A Lambda expression can only capture an instance variable in the object that creates the Lambda. Here is an example that shows this. So we have a class event consumer impl, we have an instance variable name myConsumer, and then we have a function, and in the function we have a Lambda expression, and this Lambda expression references this.name. Notice the references to this.name. Inside the Lambda body, this captures the name instance variable of the enclosing event consumer impl object. It is even possible to change the value of the instance variable after this capture, and the value will be reflected inside the value Lambda. The semantics of this is actually one of the areas where Java Lambdas differ from anonymous implementations of interfaces. An anonymous interface implementation can have its own instance variables, which are referenced via the this reference. However, a Lambda cannot have its own instance variables because it's only a function. We do not do a new class or new interface. So this always point to the enclosing object. Okay, so this is interesting. Let's repeat this. When we have anonymous classes implementations, then when we refer to this, we refer to this of the anonymous class. But in the Lambda expression, we don't define the anonymous class, so the this will point to the enclosing object, the object where we define the function inside. Note, the above design of an event consumer is not particularly elegant. I just made it that to be able to illustrate instance variable captures. Static variable captures. A Java Lambda expression can also capture static variables. This is not surprising, as static variables are reachable from anywhere in Java applications, provided the static variable is accessible, packaged, scoped, or public. Here is an example class that creates a lambda which references a static variable from the inside of the lambda body. So we have a static variable and then we do attach and we reference this static variable. The value of a static variable is also allowed to change after the lambda has captured it. Again, the above class design is a bit nonsensical. Yeah, I agree with it. This is why I said earlier that it's possible, it's not that elegant, it's not something that we want to use. There are extreme use cases for this probably. Don't think too much about that. The class primarily serves to show you that a lambda can access static variables. Method references as lambdas. In the case where all your lambda expressions does is to call another method with the parameters passed to the lambda, the Java lambda implementation provides a shorter way to express the method call. First, here is an example single function interface. So we have my printer and print, and here is an example of creating Java Lambda instance implementing the my printer. So we do call println, and so we have here the Lambda definition, and because the Lambda body only consists of a single statement, we can actually omit the enclosing curly bracket. Also, since there is only one parameter for the Lambda method, we can omit the enclosing parentheses, brackets around the parameter. Here is how the resulting Lambda looks like. My printer S2, system out println S. Since all the Lambda body that is forward the string parameter to the system out println method, we can replace the above Lambda declaration with a method reference. Here is how the Lambda now looks like. My printer system out println, and it will know to take the argument and pass it to the function. Notice the double colon. This signal to the Java compiler that this is a method reference. The method reference is what comes after the double colons. Whatever class or object that owns the reference method comes before the double colons. You can reference the following types of methods: static method, instance method on parameter objects, instance method. You can reference the following types of methods: static method, instance method on a parameter object, instance methods, constructor. Each of these types of method references are covered in the following section: static method references. The easiest method to reference are static methods. Here is the first. Yeah, so we refer to it with my class do find. Since the parameters of find, and my class do find methods match, it's possible to create a Lambda expression that implements the find parameter method reference. You can also reference a method of one of the parameters to the Lambda. Imagine a single function interface that looks like this. It receives two strings, S1 and S2. The interface is intended to represent a component able to search S1 occurrences of S2. Here is an example of a Java Lambda expression that calls strings.indexOf to search, string.indexOf. So we do S1. We call the parameter .indexOf S2. Notice how the shortcut version references a single method. The Java compiler will attempt to match the reference method against the first parameter type using the second parameter type as parameter to the reference method. Instance method references. Third, it is also possible to reference an instance method from a Lambda definition. First, let us look at a single method interface definition. Deserialize string v1. This interface represents a component that is capable of deserializing a string into an int. Now look at the string converter class. We have convert to int, integer.value of v1. The convert to int method has the same signature as the deserialize method, the deserialize method. Because of that, we can create an instance of string converter and reference it convert to int. String converter, which is an instance, convert to it. The Lambda expression created by the second of the two lines references the convert to it method of the string converter instance created in the first line. So this is a function, right? We say that this object references a function, and this function is convert to it, which we defined. Constructor references. Finally, it is possible to reference a constructor of a class. You do that by writing a class name followed by the colon new. So we need to write here the class name colon and u. To see how to use a constructor as Lambda expression, look at this interface definition. Public interface factory create. The create method of this interface matches the signature of one of the constructors in the string class. Therefore, this constructor can be used as a lambda. Here's an example. Factory string new. This is equivalent to this Java lambda expression. So receive chars and do a new string. Here we don't tell it what is the input, what is the output. We just say when we'll use this function, when we'll pass this function, we expect to receive a chars array, and we expect to create a new instance of string and return it. Okay, so this was an overview of Java lambdas. Basically creating functions. Where we had some limitations on interfaces, need to have a single abstract method. We have many shortcuts. We can remove the parentheses, remove the return. We can access external variables that are not so recommended. And finally, we saw the notation of how to reference other methods when we call them, just with the colon and how to reference the new. So